All right, guys, well done for sticking it through. You are now on day 5 of 100 Days of Code. And today I've got a fun project for you. And the inspiration for the project comes from the fact that all sorts of companies seem to be getting hacked these days. Everything from Ashley Madison to Verizon, everybody seems to be really bad at keeping your password safe. So, how can we make sure that these hackers who are in hoodies and wearing face masks don't get to you and your account? I also don't know why hackers are always portrayed like this. I mean, they're in their own house, they don't have to hide their face. But at least they're conscious of not spreading germs and staying warm, so that's good. But how do these hackers get into your account, anyways? Well, one of the most common reasons is password reuse, using the same password on 20 different sites from Google to Facebook to Skype to Spotify to all the random services that we sign up to. The problem is that when one of these sites get hacked, then the email and password combination you used to sign up is compromised. So all a hacker has to do is try out those credentials on a bunch of other websites and see if they work. So how would you know if your email and password is on a database somewhere? You can head over to haveibeenpwned.com, notice the spelling there, and type in your email to see if it was involved in a website that had been hacked. So let's try an email here, elon@tesla.com. And it tells us, oh no, it seems like this email has been pawned. And these were the websites which got hacked, potentially leaking this email and its associated password. I actually recommend you to try out your own email addresses right now and see which services you signed up to have been compromised. But if you want better security, then you'll actually need unique passwords for each and every website. And they should really be strong passwords, not 123456 or QWERTY. If I just called out your password, please change it. Now, what we're going to be building is exactly that. We're going to be building a password generator, something that's going to generate strong passwords with letters and symbols and numbers. First, it asks us how many letters would you like in your password? I would like 12. How many symbols would you like? I would like 2. And I would also like 2 numbers in my password. And then I hit enter and it gives me the password that it has generated with 2 symbols, 2 numbers, and 12 letters. So that's a pretty strong looking password, if you ask me. Now I can use this and update my passwords to something very strong and very secure. So this is what we'll be building by the end of today. But in order to do it, we first need to learn some new skills and new concepts. So head over to the next lesson and let's get started. The first topic I want to talk about today is the concept of loops, things that have to happen over and over and over again. The first type of loop I want to introduce you to is something called the for loop, and it can be used really easily in combination with something we learned in yesterday's lessons, which is lists. By using a for loop like this, we can go through each item in a list and perform some action with each individual item. So let's try it out in practice. In order to follow along, go ahead and fork the day 5 start REPL. And once I've explained the concept, then I want you to try it out yourself. But first, let's say we had a list called fruits, and it contained 3 items, apple, peach, and pear. If we wanted to access each item in this list individually and print it out one by one, then we would use a for loop. So we start out with the keyword for, and then we give a name to a single item. So in this case, we might call it fruit. And then we use the in keyword, and finally the list that we want to loop through, which is our fruits here. Now we cap it off with a colon, and we go on to the next line and notice how it's indented there. Now I'm going to go ahead and print the value of each of the fruit variables. And if I run this code, you'll see that it loops through my list of fruits, and for each of the fruits inside the list, it prints it out into the console. apple, peach, pear in that order. Now, the important thing to realize here is that basically you can imagine that behind the scenes, what this code is doing is it's taking this list of fruits and it's assigning a variable name, fruit, to each of them. So the first time this runs, fruit is equal to apple. The second time this runs, fruit is equal to peach. And we can see this even more clearly if you run it through the Thonny IDE, which I told you about at the beginning of the course. Now, if I go ahead and click on the debug icon and I step into each of the steps, you can see first it establishes that we have a list of 3 strings, apple, peach, pear, and then we go into the for loop. Now, notice on the right here, I've got all the variables being accounted for. And the first one it's noticed is the variable fruits, which holds a list of strings. Now, as I continue into the for loop, notice how it's going to look through this list of fruits, and it's going to assign the variable name fruit to each of the items, starting from the first one, apple. So now, by the time it's reached line 3, we've already got this variable called fruit that's been assigned to the value of apple. And so at this point, printing out the value of this fruit, it's obviously going to print out apple, as you'll see in the next step. There we go. Now, once I'm done here, then it's going to loop back to the start of the for loop. And now this variable fruit is going to be assigned to the next value inside the list of fruits. So now notice how the variable fruit is attached to the value peach. And then it continues this and so on and so forth until it prints out each one of the fruits. And this really emphasizes the most important aspect of loops. The loop allows us to execute the same line of code multiple times. In this case, we're executing the print statement 3 times, but our for loop isn't limited to just executing a single statement. We don't just have to print out the name of an item in the list. We can execute a whole block of statements multiple times, and we can do many things inside this for loop, and by inside, I mean indented. So let's say that in addition to printing out the fruit, I'm going to write another print statement, and I'm going to not only print out the name of the fruit, but I'm also going to say fruit plus space plus pi. So when I run this code, what do you think will happen? Well, it prints out apple, and then it prints out apple plus pi. And then it goes back to the start and it assigns the variable fruit to the next item, peach, peach pie, pear, pear pie. So this is how we can implement a simple for loop that loops through a list and assigns a variable name to each of the items in the list in order. And then inside the for loop, after the colon, after some indentation, we can do something with that temporary variable for each of the items. Now, I've been talking a lot about the concept of being inside a for loop versus being outside a for loop. And this is really, really important. Whenever you see a colon, say in our if statements that we saw previously or the for loop that we're using here, the indentation is really, really important, because if it's indented, then it means that it's inside the for loop, and these instructions will get carried out for as many times as the for loop will need to repeat. Now, if I decided that I wanted to, say, print my fruits, so my list of fruits up here, and I put it inside my for loop, so indented after the for loop, then as you can imagine, it's going to print that for as many times as the loop runs, which is going to be 3 because there's 3 items in our list. Now, if I had indented that back to the beginning, so now it's no longer inside the for loop, then it's only going to print once, and it's going to print it after the for loop is done. So notice how it's doing the whole apple, apple pie, etc. And then once the loop is finished, then it jumps to the next line and carries out this instruction. So the indentation is really, really important, and you have to be really careful with this. Have a play around with this code And if you're still struggling to see how it works, then move the code over to Thonny and step through each step one at a time and see how it works. But I hope you're starting to see how loops are really handy at executing an instruction over and over and over again, getting the computer to save us time and energy. A really good example of when loops would come in really handy is, you know how Bart Simpson gets punished and has to write out a sentence over and over again on the blackboard? Well, if only Bart was a programmer, then he would be able to use loops to do this, and he would be able to chill in the corner. Now, once you're happy with this type of for loop, then head over to the next lesson where I've got a coding exercise that's going to put your knowledge to the test. All right, so I'll see you there. Head over to day 5.1, the average height exercise. Now, the instructions are that you're going to write a program that's going to calculate the average student height from a list of heights. So, for example, let's say we had a list of student heights that looks something like this. Then you're going to be using a for loop, hopefully, to figure out the average. And the average can be calculated by adding up everybody's height and then dividing it by the number of students inside the list. And then I want you to round it to the nearest whole number. Now, notice how we've got some starting code here, and this is just for us to be able to input a list of student heights for testing and see if your code actually works. So if you go ahead and run the code, then you'll notice that it asks you for a list of student heights, and the input is going to look something like this. There's just going to be a bunch of numbers separated by a space. So if I go ahead and paste that in there, then I hit enter, then notice how this line on line 5 is going to print it out just as a normal list full of numbers. Now, Python has some really useful functions, as we've seen. We've seen that we could use the len function to calculate the size of a particular list. So if I go ahead and print my length of student heights, and then I paste my student heights in here, then you can see that I get 5 printed by calculating the number of items in here. Now, Python also has something called sum, and this gives us the total of all the items from a list. So in this case, all of these added up would be 857. Now, your job, though, is to figure out how these functions actually work under the hood. In order to fully complete this challenge, you can't use the len function or the sum function. Instead, you have to figure out another way through the use of for loops where you can add each of the items inside the list together, and you can use a for loop to figure out how many items there are in this list and use that to calculate the average. So you can't use either of these functions, and instead you have to rely on what you learned in the last lesson to complete this challenge. So have a think about it, and once you're ready, give that a go. Now, we know that we can't use either of these functions, the sum function or the length function, because if we could, then this challenge would be super easy and we would be able to calculate the average by getting the total height, by getting the sum of all the items inside student heights, and then we could calculate the number of students by using the length function to calculate the number of items inside the list, and then we would get the average height by dividing the total height by the number of students, and then we would be able to round this value off and print it out. But this, as you noticed, doesn't use a single for loop, and the last thing we learnt about was a for loop. So this is definitely not the right way to solve the challenge. It works, but what I wanted you to do is to figure out how the sum and the len functions work under the hood. How is it actually implemented? And to do that, we have to use a for loop. So let's have a think about how we would first tackle this one, where we get the total of all the items inside student heights. So we basically want to add each of them together until we get the total. Now, we can do this by simply using a for loop, as you've learned in the last lesson. So if we start off total height as 0, and then we write a for loop and we say for height in student heights, and then we add a colon, then now we're going to loop through each of the heights inside this list, and we're going to add it to our total height. So we can say total height equals previous value of total height plus height, or as you might remember, the shortened version of this is just total height plus equals each of the heights. So now we can go ahead and check whether if this worked by printing out the final value of total height. And notice how I'm doing it outside the loop by making sure that it's not indented like this. So let's run our code, and I'm going to paste in those numbers as the demo numbers, and then we get the value total height is 857, which if you take a calculator, you'll be able to verify it's exactly right. So now we've basically replicated how the sum function works. And now we can try and replicate how the len function works. We know that basically the len function figures out how many items are in a particular list. How can we do this using a for loop instead? Well, what if we do something similar to what we did above, where we start off the number of students as 0, and then we write a for loop for student in student heights, and inside our for loop, all that we do is we add 1 to our number of students each time our for loop runs. And if you remember from the last lesson, I said that the for loop will run for as many times as there are items inside the list. If there are 5 items inside the list, then the for loop is going to run 5 times, which means this line of code is going to be called 5 times, which means we add 5 to our number of students, and we end up with the total length of the list. So now let's go ahead and print this number of students out and run our code. And I'm going to paste in the same 5 numbers in the example input. And you can see that the first value that comes out is my total height. The second value is the length of the list, the number of items in the list, which is 5. We can verify that. And the final one is the average, which matches up with the example output. So now let's get rid of our print statements by commenting them out. Now, one of the things I want to point out to you that you might have noticed is that in the first for loop, even though we're looping through the same list, I've called each of the items height, and in the second for loop, I've called them students. Now, whatever we name each of the items inside the list, it's totally up to you. You could call it H, you could call it X, you could call it basically anything you want, as long as you are consistent with using it inside the for loop. So if you're calling each of the items inside the list H, then when you're using it inside the for loop, when you're modifying it or doing something with it, then you're going to refer to it by the same name. Now, usually it's a good idea to give it the name which is the singular form of each of the items in the list. For example, previously we had a list of fruits, so each item was called fruit, the singular form. And in this case, we have a bunch of heights, so each of them I've called height. In the second for loop, I've decided to call each of the items a student. Now in this case, even though you have 2 for loops, you can call them the same thing. But sometimes I find it a little bit confusing to have the same name in 2 for loops. I prefer it this way, but it's totally up to you. Just follow the good practice of using a singular form of whatever is contained in a list when you write a for loop like this, and you'll have less trouble down the line. So now that you've gotten a taste for for loops, it's time to complete another challenge, which is going to stretch you a little bit further. Head over to day 5.2, highest score, and we're going to get a list of students' scores, and it's a list of numbers again. The idea is that you're going to write some code that's going to output the highest score in the class. So you're going to look through this list using a for loop, and figure out which of the scores inside the list is the highest value. Now, we can see pretty much at a glance that inside this list, 91 is the highest. But remember that when you test your code, you won't be able to see the input, so you won't be able to cheat that way. Instead, you have to do this using code. Now, just as in the last lesson, I mentioned that Python has some pretty useful functions that helps us do a lot of these commonly needed things very easily, such as the sum and the len functions. Well, in this case, there's actually something called the max function. So if we pass a list, let's say the student scores list, into a max function, and then I go ahead and print out the maximum value from my list of student scores. So let's run this code, and I'm going to use the example input, so a bunch of numbers separated by a space, and hit enter, and you can see it tells me that 91 is the highest value. Now there's also the min function, which basically will give me the lowest value inside a particular list, which in this case is 55, but that's too easy. I don't want you to use the max or the min functions. Instead, you have to use what you've learned about for loops to replicate the underlying functionality of this max function. Because people tend to use Python to do a lot of data manipulation, to do a lot of mathematical calculations, it has a lot of these convenient functions for you. But let's say you move to a different language and you work on something else, then these might not exist. So understanding the underlying logic and being able to write out the code using things that every programming language has, like the for loop, will mean that you will become a much, much better programmer in the process. So try and replicate the functionality of the max function, and the output should have the words the highest score in the class is, colon, and then a space, and then the actual max value. So this is what should happen. Pause the video now and have a think about how you would write your code in order to get hold of the maximum value from a list. All right, so did you manage to complete this challenge? If not, and if you want to see how I do it, then continue watching along. The first thing we want to do is we probably want to get hold of each of the scores inside our list of student scores. So I'm going to write something like for score in student scores. So again, keeping that convention of singular from plural. Now inside the loop, what can I do? Now let's say I had a variable called highest score, and I'm going to start it off as 0. And then inside my loop, I can use an if statement to check, well, is the current score that I'm looping through greater than the highest score that I've got? Well, then if so, that means this current score should actually be the highest score. So I can set my highest score to equal, single equals means a sign, double equals means checking, remember? And this loop will continue running until I've checked through all the scores inside my student scores, and I've got the highest score stored inside this variable. So now I can go ahead and print the sentence. The highest score is this particular value. So I'm going to use an f string to insert my highest score variable inside here. And if I run my code and use this example input, then you can see it tells me the highest score in the class is 91, which matches exactly with the example output. Now, if you're at all confused about how this code works, then I recommend, again, pasting it into Thonny like this. So you've got a list of scores, and then you've got the code in the solution, and click on debug, and you can see how we actually step through each of these stages, where we start off with a highest score being equal to 0. So that's where it is. And then we continue into the loop where we go through each of the scores inside the student scores. So the first one is going to be 78. So now we've got this variable score, which is tied to the value 78. And then we go and check if the score, which is 78, is greater than the highest score, which is 0. Well, that's obviously true, right? So if that's true, then it's going to carry out the next line of code, which is that the highest score is now equal to score. So now notice how this highest score variable is going to update to the first value because 78 is greater than 0. Now we go back to the start of the loop and we go to the next value, 65. And 65 is now checked against the highest score. Is 65 greater than 78? Well, no, that's not true. So this is false, and so the highest score is left alone. And we continue back to the next value. So now our score is equal to 89, and our highest score is still equal to 78. Is 89 greater than 78? Yes. So now we reset the highest score to the new value, which is 89. And it continues this loop until it gets to the end and it's found the highest value and it prints it out into the console. Play around with the debug and step through each of the stages to see how it works and compare it with what's happening with each of the variables on the right. This is a really, really useful way of wrapping your head around all of this complex looping and conditionals. And once you've understood everything that's going on, then you can continue to the next lesson where we're going to talk about another type of for loop, the for loop using a range operator. So for all of that and more, I'll see you on the next lesson. Now, up to this point, we've only been using for loops in association with lists. So we've been looping through the list and getting hold of each of the items in the list and then doing something with it, right? But we're not always going to be working with lists and using for loops. Sometimes we might want to use a loop completely independent of a list. And a good example of this is when Carl Gauss, the German mathematician, was just a child. When he was 10 years old, his math teacher gave him an exercise that she probably thought would tie him up for a little while. And the idea was to get him to add all of the numbers from 1 to 100. So 1 plus 2 plus 3 plus 4 plus 5, etc. all the way until 100. And even though she thought this would keep him busy for an hour or so, getting this young child to add up these numbers, and I can have some peace and quiet scrolling on Facebook, but unfortunately he came back to her within 2 minutes and gave her the answer. So how did he work it out? Well, he was actually a really smart kid, and he figured out that if you flip the numbers around, so 100 plus 99 plus 98, and you look at both of these two lines, you can see that 1 plus 100 equals 101, 2 plus 99 equals 101, 3 plus 98 equals 101. Basically, if you tie all of these numbers together, there's actually 50 pairs of 101. So he could simply just do 50 multiplied by 101, which is 5,050. And that's how he figured out the answer. But we can actually outshine Gauss because we can do this calculation in less than a minute just by writing a few lines of code. But in order to do this, we first have to learn about using for loops with the range function. Now, the range function is something that is really, really helpful if you want to generate a range of numbers to loop through. And the syntax looks something like this. So we've still got our for and our in keywords highlighted in blue. But instead of looping through a list, we define how our loop is going to work by creating a range. So in this case, I'm creating a range between A and B, and then I'm going to get hold of each number in that range and do something with that number. So for example, if I wrote 4 number in range, and then my range is going to be 1, 10. So this is going to be the range that I'm going to create between 1 and 10. And then I want to get hold of each of the numbers inside that range. And this is going to be between 1 and 10 and not including 10. So if I go ahead and print out the number that I create from my for loop, then you'll see that what happens is it prints 1, 2, 3, 4, 5, 6, 7, 8, 9, but not the last digit, which I've included here. So if I wanted all of the numbers from 1 to 10, I actually have to set a range between 1 and 11. And now when you run the code, you can see that it goes from 1 all the way up to 10. Now, by default, the range function will step through all the numbers from the start to the end, and it will increase by 1. Now, if you want it to increase by any other number, then you have to add another comma to the end of it and specify how large you want the step to be. So let's say we change the step size to 3. Now, if I rerun the same code, you'll see that it goes from 1, and then it steps by 3 to 4, and then it steps by 3, and then it steps by 3, finally to 10. Now let's come back to the problem that I mentioned at the beginning of this lesson. How can we add up all of the numbers from 1 to 100 by using code? Well, it's going to involve the for loop, and it's going to involve the range function, because we're going to get hold of every number in the range between 1 and 100. So we need to write 101. Once we've got hold of all of these numbers, it's as simple as using a accumulator. So let's say total equals 0. And then inside the for loop, so that means indented, we're going to say total plus equals number. So now it's going to add every number in this range to the total starting from 0. And this is basically going to give us the sum of every number from 1 to 100. So let's go ahead and print it out and see if it matches Gauss's value. And there you have it, 5050. So now that we've beaten Gauss at his own game of math using programming, let's head over to the next lesson and try to complete a challenge using the range function to see if you manage to internalize and understand everything we talked about in this lesson. So for all of that and more, I'll see you there. Click on 5.3, adding evens. The exercise is kind of similar to what Gauss had to do that I showed you in the last lesson. But in your case, I want you to calculate the sum of all the even numbers from 1 to 100, including 1 and 100. So, for example, it might be 2 plus 4 plus 6 plus 8 and so on and so forth until you get to 100. It's a little bit more complicated than what the 10-year-old had to do. And the important thing to remember is that there should only be one print statement in your output. It should just print the final total and not every step of the calculation. So have a think about how you might solve this challenge, pause the video, and try to give this a go. Alright, so there's actually quite a few ways that you could have solved this challenge. Now, one of the ways would have been using what we learned from the last lesson and the ability to create a range function using a different step size. I'll show you what I mean. So let's create a for loop where we say for every number in the range between 1 to 100, so that's 101, then we're going to do something with each number, right? Namely, we're probably going to create a variable called total, and then we're going to add each of the even numbers together and accumulate it inside this variable. Now, remember that I mentioned that the range function actually has a third thing that you can add to it, not just the start and the end, but also the step size. So we can change the step size to 2, and then now what it's going to do is it's going to go through 1 to 100, and it's going to increase the step size by 2. So that means if we print this range as it is right now, it's going to give us 1 plus 2, which is 3, plus 2, which is 5, and so on and so forth. But if we change the range to start off from 2, which is the first number that we have to start adding in our sequence, and then increase it by 2 every single time, then we end up with a range that includes all the even numbers up to 100. And I'll show you if I run this code right now. So the next part is simple. All we have to do is to add the number to the current total. So total plus equals number. And then finally, outside the for loop, we can go ahead and print that total. Now, when I go ahead and run this code now, it's going to give me just the total. Now remember that the indentation really matters, because if I have it like this, then it's going to give me the total for every step of the calculation, because it's now included in the for loop and will be executed for as many times as the for loop runs. But if I remove the indentation, then the for loop is just this, and this is outside of it, so it's only going to give it to me once everything has been done and I've got the final total. And it's the correct solution. But you might have also done it in a different way. You might have said for number in range 1 to 101, and you had some sort of another total, let's call it total 2, and started at 0. And then we say that if the number modulo 2 is equal to 0, so if it's even essentially, then we're going to add this number to the total 2. Finally, outside of the if and outside of the for, we're going to print the final total. And now if I just run the code, then you can see I get exactly the same number as before. So if you chose to solve this challenge in either of these ways, then you've succeeded. They're both right. And there's probably even other ways that you could solve this as well. But these two, I suspect, will be the most popular approaches. Now, in the next lesson, I've got another coding exercise for you. And it's probably one of the top interview questions that programmers get asked when they're being interviewed for a job. So head over there and give it a go. All right, guys, I've got a fun coding challenge for you today, and it is a problem called FizzBuzz. Now, this is probably one of the most asked questions at interviews for programmers, because it tests the way that you think, and it allows the interviewer to see how you use your logic to solve a problem. And the problem we're going to tackle is a children's game called FizzBuzz. Last time I checked, the programmatic solution was actually up on Wikipedia, so I recommend reading the Wikipedia article only after you've solved this programming challenge. The rules of FizzBuzz are really simple. Basically, you have a bunch of kids who sit around in a circle, and going clockwise, the first kid says 1, the second kid says 2, but then when a kid encounters a number that's fully divisible by 3, then instead of saying that number, he's going to say fizz. And when the number is divisible by 5, instead of saying the number, they should say buzz. And if the number is divisible by both 3 and 5, for example 15, then they should say FizzBuzz. So your program is going to replicate this for all the numbers up to and including 100. To start off, it'll probably look something like this. It's going to print 1, and then on the next line it'll print 2, and then fizz, because 3 is divisible by 3, and then 4, and then 5 is divisible by 5, so it's buzz, and then 6 is fizz because it's divisible by 3, and so on and so forth. This is what your program has to do. Take a look at the instructions, make sure that you understand what it is that your program has to do, and then pause the video and try to give this a go. All right, so the first thing we have to do is to create a range, right? So let's say that for number in range, and our range is between 1 and 100, so we have to include 101 in here. And what we want to do is we want to check whether if the number is divisible by 3, divisible by 5, or if it's divisible by both 3 and 5. Now, we could write our code by doing this in order, right? We could say if number modulo 3 is equal to 0, then it's divisible by 3. So you might think that you could write the code like this, but there's a crucial problem in the logic here, namely that we know that the if, elif, else statements will stop once it's found one statement that's true. For example, if we take the number to be 15, 15 divided by 3 is equal to 0, so it's going to carry out whatever instruction is inside this if statement, and then it's going to be done with it. It's going to skip this one, and crucially, it's going to skip this one, which is what we really need. instead of structuring our code like this, what you might have done and what you should have done is in fact have this at the top. So first check if it's divisible by 3 and by 5. And then if that's not true, then check to see if it's divisible by 5 and then divisible by 3. Or the other option works as well. You could do it like this. Because these two have no overlap in terms of the results, then it doesn't really matter. So now we can finally write our code, because we can say, well, if the number that we're currently encountering is divisible by both 3 and 5, then we have to print fizzbuzz. If it's only divisible by 3, then we're going to print fizz. And if it's only divisible by 5, then we're going to print buzz. Now, that still leaves the remaining numbers, right? Because the remaining numbers, which don't fit any of the criteria, should just be printed out as the number. We can catch that quite easily with an else statement that catches basically every other number, in which case we're just going to print the number. So now if I go ahead and run this code, then you can see that all the way from 1 to 100, it's been able to work out which ones are fizz, which ones are buzz, and which ones are fizzbuzz. How did you get on with it? If you got stuck, or if you don't understand why this logic matters, then I want you to try both versions that I showed you and see it step by step using the Thonny program, just as we did before. That way you can visualize what's actually happening in terms of the logic and how it's flowing from one step to the next to the next. Now, once you've done that, then go back to your exercise and try to complete it. It's really, really important that you don't just say, oh yeah, I understand now. It's a really good idea to make sure that your code actually works at the end of the day and to write the code yourself. So today we've learned all about loops and we're going to apply it in our final project. So that's what's waiting up for you in the next lesson. So head over there once you're ready. Now that we've learned all about loops in Python, we're finally ready to tackle our final project of the day, which is the PyPassword generator. Our program will ask us, how many letters would you like in your password? So I will say, I would like a long password, let's say 14. How many symbols? 3. How many numbers? 4. And it's going to generate me a password that is almost completely impossible to crack by any hacker, no matter how talented they are. So the project of today is to build this password generator. If you head over to this particular replit, password-generator-start, then you'll see that here I've already included for you a list of all the letters in the alphabet from A to Z, including the uppercase and lowercase letters. I've got a bunch of numbers and a bunch of symbols that are usually accepted by websites in the passwords. And I've also created the inputs that you saw when we did the demo. So it's going to ask us how many letters, how many symbols, how many numbers, and then you're going to turn all of that knowledge, as well as using these lists and what you've learned about loops, into the same password generator that you saw in the final demo. So have a play around with the final demo yourself, and then have a think about how you might be able to achieve this goal of creating a random password for the user based on the number of letters, symbols, and numbers that they want. Now, there's 2 levels to this project. You can either go for the easy version, where all you have to do is generate your password in sequence. So for example, if the user wanted 4 letters, 2 symbols, and 2 numbers, then it might just look like this: 4 letters, and then 2 symbols, and then 2 numbers. So they're in sequence, right? First you've got the letters, then you've got the number of required symbols, and then you've got the required numbers. So this is the easy level, and then there is the hard level. And the hard level requires you to generate the password in a completely random order. So instead of having it being letter, symbol, number, it should be maybe letter, and then a symbol, and then a number, then a letter, then a symbol, and then a number. But notice how this is completely random. Every single time you generate it, the order of where the symbols and where the numbers appear in your password are completely random. So for example, if you look at the demo version and I do the same thing, 4 letters, 2 symbols, 2 numbers, where the numbers and where the symbols occur are completely unpredictable. And every single time I generate a new password, it's going to switch it up again. So that's the hard level. I recommend trying the easy level first, and then once you've managed to do it, then take yourself up to the hard level if you think you're up to it. But remember that if you're doing the hard level, you might have to do a little quick Google around in order to figure out how to do something that you might not have seen before. But it's all part of the challenge, and I hope you'll take it on with vigor. So pause the video now and try to complete the final project. All right, so let's first tackle the easy level, where we're just generating a password with the required number of letters, and then the required number of symbols, and then the required number of numbers. So let's go ahead and tackle this one first. Now, we know that we've got these lists which we can draw from, and we know that we can use the random module to get hold of a random item from the list. So all we have to do is first get 4 random letters. So let's say that we had a password which just started out as an empty string. Then we can use a for loop to loop through all of the characters that we need to create for our password. For example, I might say for car, short for character, in the range of from 1 to the number of letters that the user wanted. So in this case, if the user wanted 4 letters, then it will be a range from 1 to 4, but not including 4. So it's actually from 1 to 3, which is only 3 characters. In order to modify this, we have to do what we did always before, which is just to add 1 to the end of our range. So now we're going to create a range based on the number of letters that the user wanted. And I'm just going to go along with the assumption that the number of letters equals 4. Let's just pretend that's what the user will enter. So then this range becomes 1 to 4 plus 1, which is 5. So the range is in fact going to be 1 to 4. For every single number in that range, from 1 to 2 to 3 to 4, I'm going to generate them a random letter, and I'm going to pick it out of this list of letters. To do that, I can either generate a random number and use it as the index, or you might have seen previously, I showed you the random.choice function. And inside this random.choice, we can pass a sequence, which in our case is the letters list. Then it will look through this list of letters and it will give us a random item from that list. So now that random letter is going to be something that we're going to need to add to our password, right? So we can set this equal to a random character. And now let's go ahead and just print it out. So let's say we want 4 letters in our password, and we can type anything for the other ones. But notice how when the for loop runs, it's given us some random characters that it's picked out of our letters list. So there's an A, there's a capital P, there's a D, and there's a capital J. How can we add each of those letters to our password? Well, we can use the string concatenation that we learned very early on in day 1. We can say password equals the previous password plus the random character. Of course, the shortened version of this is just password plus equals random character. And now let's go ahead and instead of printing the random character, let's print the password at each stage of the loop. And again, I'm going to choose 4 letters. And you can see that the first time the loop runs, I get an M. So password is equal to M. The second time I get a Q, so I add the Q onto the M. I get MQ, and so on and so forth until I get these 4 characters in the beginning of what seems to be my random password that's going to be generated. Now, if you wanted to, you can actually simplify this down to just one step, because instead of having this intermediary, which is the random character variable, we can simply just replace it with the code, like this. So in this case, we're getting a random choice from our letters list. So we get a random letter, and then we add that to our password. Now that we've done that for the letter, then it's pretty easy to see how we can continue doing this for the symbol and the numbers. We just have to keep adding it to the end of our password. So let me quickly write out the code for this. So now when the user requests that they want 4 letters in their password, then we generate a range from 1 to 5. And then for each of those positions, we generate a random letter in order to fill the password. And then we add on the required number of symbols and the required number of numbers. And finally, we print out the final password. Let's go ahead and run this code. And again, I'm going to choose 4 letters, 2 numbers, and 2 symbols. And I end up with my final password, which fits exactly that criteria, and it looks pretty random. But the only problem is that if a hacker knew that you always have 2 symbols at this position and 2 numbers at this position, then it's very easy to crack that password, because in order to get the last digit, for example, they only have to try 9 different variations: 1, 2, 3, 4, 5, 6, 7, 8, 9. And this just limits the strength of your password. In order to tackle that, you would have to tackle it at the hard level, which is, how do you get a password that has all of these letters and numbers in a completely random order? To do that, we mentioned that you have to do a bit of Googling, because it might require something that you haven't done before. But in essence, you've got access to everything you need to perform the logic. So if you haven't given that a go, then this might be a good time to pause and have a think about how you might structure the logic, or how you might create a flowchart to express this logic that you would want. And once you've done that, and if you want to see the solution and walk through it with me, then come back here and I'll show you how to do it. But first, give it a go. All right, in order to tackle the hard level, what we essentially need to do is, instead of adding each of these letters into a string, we actually want to add it into a list. So I'm going to copy all of this that's here, and I'm just going to comment it out, and I'm going to paste it under my hard level and work on it here. So instead of using a password string, I'm going to create a list, and to better describe it, I'll change my variable name to password list. So now, instead of using password to add each of these letters and numbers and symbols, I'm going to be adding it to my list. Now, to add things to a list, you can use the same syntax that you did with strings, which is to add the new item into the list and to update the old list. You might be more familiar, though, with the syntax, which is append. And both of these work. You can use either of them if you want, but they'll end up doing the same thing, which is to add each of those things you've generated in the order that you've generated to your password. So we end up now with a list with 4 letters, 2 symbols, and 2 numbers, all stored as strings because of the quotation marks around them. So now that we've got a list, well, then we have to think about, well, how can we shuffle our list? How can we mess up the order of the items in our list? And that might take you to Google, and you might search for something like how to change the order of items in a list. And then we also have to add our keyword, which is Python, because there's obviously a lot of other programming languages. And we come up against our first Stack Overflow question. How can I reorder a list? Well, that sounds kind of like what I want to do, right? So if we scroll down, you can see that the way to do it is either using a for loop like so, or to simply use the shuffle function. This is a much simpler way because it allows us to update the existing list just by calling the shuffle function on it. And this one actually requires us to create a new list, and we have to create a bunch of random numbers for the order and then to reorder them using a for loop. So I'm going to go with this version, and let's try it out. Instead of printing password list, let's print the password list before the shuffle, and then let's use the random.shuffle and pass in the password list, and then let's print the outcome of that shuffle. So let's print the password list again. So now you can see that we've got a version before and then we've got a version after. So if I run my code and I write again 4 letters, 2 symbols, 2 numbers, you can see that previously it was ordered in the order that we added each of the characters. After the shuffle, they're now pretty much random. There's letters in random places, there's symbols in random places. So if only we could turn this back into a string, then we've got our password that's nicely shuffled. So how can we turn it back into a string? Well, we could simply use a for loop, right? We could say for each character in the password list, we're going to add it to a variable called password, which is going to start off again as an empty string, and then we're going to add to it. So we're going to say password plus equals each character in our password list. And now if I go ahead and just print my final password, I'm going to add a F string as well. Let's say your password is, and then let's insert the password. And now if I run my code and let's say I want 12 letters, 3 symbols and 4 numbers, then it's going to generate me an entire password that's completely randomized in terms of the orders of the symbols and the numbers. And I've now solved the hard part of this challenge project. Did that make sense to you? Did you manage to get it to do what you wanted to do? If you're at all confused about the code that we've covered here, then be sure to check out the final project that I've got here, which is the app generator end, and take a look at how the easy level is implemented, how the hard level is implemented, and try switching it around so that you really get to understand it. Try, instead of maybe getting the user to tell you how many letters, how many symbols, how many numbers, instead just define those yourself or use a random number of letters, numbers, and symbols. Play around with the code until it starts doing what you want it to do and it starts making sense. But I hope you had fun building this project with me today and learning all about loops. On the next lesson, we're going to be learning more about these things that we've been using a lot, which is Python functions. So I'm going to bid you good night for today, and hopefully I'll see you bright and early tomorrow, and we'll learn some new skills and work on some new projects. So that's all from me. Good night from Angela. Hey, well done for completing day 5. Now I know that day 5 had a really difficult challenge at the end, so it must have taken some perseverance that you had to draw out of yourself in order to actually do it. Now, at this point in time, you might be feeling a lot of the same feelings that I had when I first started learning how to code, which is this overwhelming sense of like, maybe this is not for me because everything is so overwhelming and I don't understand it and it's just not clicking. Maybe I'm not meant for this. Maybe I was born to be a lobster, instead of a programmer. But you know what happened? I continued, I persevered, and at some point it actually all started clicking. It started making more sense. So just trust in the process, keep showing up and just put in those reps every day. And I promise that by the end of the course, you will not feel like this. You will feel like you're on top of this and you got it. This is going to happen. So keep going, keep doing what you're doing. You're doing a great job.